In this next video, we're going to begin our conversation about special solutions. Before we get to those, let's review story problems with variables on both sides. So consider the following situation. Jeff and Claudia are both saving money for a new pair of shoes. Jeff starts with $10 and saves $30 per month, and Claudia starts with $50 and saves $20 per month. Now notice that we're comparing two different situations, and we see this word per month twice. That means I'm going to have an equation with variables on both sides. After how many months will they have saved the same amount? And I'm going to, same amount means equal amount. There are two ways to solve this. The first way would just to be calculate it by hand. What do I mean by that? Well, here we go. For Jeff, at month 0, and month 0 means at the beginning, he's starting with $10. Claudia, on the other hand, starts with at month 0 starts with 50. Well, after month 1, how much do they have saved? Well, add 30 to Jeff. 10 plus 30 is 40. For Claudia's month 1, add 20 to 50, 70. So there's still some differences. On month 1, they still don't have the same amount saved, so I just continue. On month 2 for Jeff, add 30 more. I get 70. Now here's a point where somebody might stop and say, hey, they have the same amount. They both have 70. But remember, Claudia by month 2 doesn't have 70. She has 90. Okay, the months have to be the same, and the amount of money has to be the same for us to say after how many months will they have saved the same amount. So let's continue. At month 3, continuing to add 30, Jeff has 100. On month 3, for Claudia, plus 20 is 110. So you notice that these amounts are getting closer and closer each month. Let's check and see if our next month they're going to be the same. So plus 30 is 130. And for Claudia, plus 20 is 130. So there you have it. On month 4, they both have saved $130. So that's the answer to my question. Hey, after how many months will they have saved the same amount? 4 months. So my answer, 4. Well, that didn't take too much time, but is there a faster way? And I think yes, there is. So the faster way would to write an equation. For Jeff, his expression is going to be based on $10 plus $30 per month. Remember, 10 plus 30, x for that per month, is going to have the same amount as Claudia, who starts with 50 and adds 20 per month, so 20x. And I just solved my variable with both sides equation. This has 30x, that's my variable side. This is my number side. So since this is my variable side, minus 10, I'm left with 30x. 50 minus 10 is equal to 40. Since this is my number side over here, I'm going to get rid of the 20x by subtracting, since it's positive. And I'm left with 10x equals 40. I divide by 10, and I'm left with x equals 4. So you notice I got the same answer either way. I really want you to look carefully and consider this following situation. Jamal and Kim are both saving money for a new bike. Jamal starts with $20 and saves $30 per month. So I'm going to start with my equation by writing it as I read it. Kim, okay, we want to know after how many months will they have saved the same amount. We want to know when they're equal. So equals Kim starts with $10 and saves $30 a month. Now, before you just get stuck on the equations and solving and whatnot, consider this. If Jamal starts with 20 and adds $30 to his account per month, and Kim starts with $10 and adds $30 per month, when will they have the same amount? Well, they're never going to have the same amount saved, because they keep adding 30 and they started at 2 different places. So to demonstrate, Jamal starts with 20. By month 1, he has 50. By month 2, he has 70, sorry, 80. Need to learn to add. Hey, Kim starts with 10, adds 30, gets 40, adds 30, gets 70. And you can see, no matter what happens, they're going to stay. That's $10 apart, that's $10 apart, and that's $10 apart. And if I even continue to 3 months, 110, 100, still $10 apart. Because Kim started with $10 less and they're adding the same amount each time. This type of equation is what we say has no solution. We can't find the number of months that they will have the same amount because they're never going to have the same amount. Now, if I didn't recognize that and I was like, dun 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 dun, dun, just solving my equation, notice what happens. I look to see my variables and I notice that my variables are the same. So I say, okay, whatever, we'll just make this the variable side and this the number side. So if this is my variable side, I'm minus 20, and I'm left with 30x equals negative 10 plus 30x. Then I get rid of minus 30x. Well, what happens? What's 30 minus 30? It's a big fat 0. There are no more x's. 0 equals negative 10. No variables. And is 0 equal to negative 10? No, it's not. Then I have no solution. All right, consider a different situation. Melanie and Jason are both saving for a new TV. Melanie starts with $50. Okay, so here's Melanie. Starts with $50. Here's Jason. Starts with, $50. Interesting. And Melanie saves $100 per month. So at month one, she's going to have $150. What about Jason? How much does he save per month? $100. $150. So they have the same amount to begin with and after month one. And what do you think that pattern that's going to continue? At month 2, they're going to have the same amount. And at month 3, they're going to have the same amount because they started with the same amount and they're continuing to add the same amount. So when they ask how many months will they have saved the same amount, the answer is every month. Every month they're going to have. In math, we say that there are infinite, meaning more than you can possibly name, infinite solutions. This is our second type of special solution. So let's kind of go over the 3 types. So when you have equations with variables on both sides, there are 3 possibilities for the answer. One solution is a possible answer. So that's going back to our first example. We could figure out at how many months they had the same amount. At 4 months, they had the same amount. Before 4 months, they didn't. And after 4 months, they won't. Okay. Only at 4 months will they ever have saved the same amount. Then we also have no solution. Hey, remember that's like Jamal and Kim, where they start with different amounts and add the same amount each time. They are never going to have the same amount of money. And we also have all real numbers or infinite solutions. We're going to call them infinite solutions. Okay, where all numbers are a solution. You'll notice this fancy 3 equals 2. Well, is 3 equal to 2? No, remember that's a sign. If I don't recognize it from the story, hey, that's no solution. All real numbers or infinite solutions is when they're the same on both sides. Let's go back to this example right here. If I wrote out my equation, 50 plus 100x equals 50 plus 100x. Okay, if I minus 50, that gives me 0. And if I minus 100x, that also gives me 0. So I'm left with 0 equals 0. When they're the same on both sides, that's a telltale sign that it's an infinite solution. Okay, let's practice this a few times. So what do I do if I get this equation? All right. 15x plus 20 equals 15x plus 40. You can try and relate it to a story problem in your head and make a decision, or you can solve the equation. So if I were to read this story problem, I'd say, this person had a $20 to start with and added $15 per month. This person started with 40 and added $15 per month. Are they ever going to have the same amount of money? To me, right now, I'd say no. There's no solution. Now, if you didn't do that to begin with, how could I do that with algebra? Well, let's show you. They have the same amount of variables on both sides, so I'm just going to make this my variable side and this my number side. If this is my variable side, minus 20, I'm left with 15x is equal to 15x plus 20. I minus 15x from both sides, and I am left with 0. Whenever there's nothing left, you have to write a 0. 0 equals, that's gone. I don't have to write 0 here because I do have a 20 left over, equals 20. Are they the same number? Is 0 equal to 20? No. Therefore, I write no solution. Okay, let's try it again. If I have 40 plus 10x equals 40 plus 10x, tell myself a story. This person starts with $40 and adds $10 a week. Starts with $40 and adds $10 a week. Hey, I think because they start with the same amount and add the same amount, that there's going to be infinite solutions. But how could I check that with algebra? I can solve it. Here we go. Draw my line, and I have variables on both sides that are the same amount. Let's make this our variable side and this our number side. If I minus 40, I'm left with 10x equals, that's 0, that's gone, but I'm left with 10x. If I minus 10x from this side, because this is my number side, and minus 10x, notice what's left over. 0 equals 0. When they are the same, 0 does equal 0, then I have an infinite solution. All right, I look at this problem and I say, okay, this person starts with $30 and adds $2 a week. This person starts with $10 and adds $4 a week. I'm not really sure what's going on. I don't know if they're gonna always have the same amount or never have the same amount. So I'm going to actually solve this equation. I notice that my variables are different, so it doesn't matter which side is my variable side. Here's my variable side, this is my number side. So I'm going to get rid of my variable on the number side and do that on both. That zeroes out. I'm left with 30 equals 4 minus 2 is 2. And I bring down the 10. If this is my variable side over here, I want to minus 10. And I'm left with 20 equals 2x. Divided by 2, x equals 10. Now, do I have just plain old numbers on both sides? Nope. So then it's not infinite solutions. And it's not no solution. This has one solution, and there's one solution. And only at one time are these ever going to be the same, when x equals 10. Let's try another one. If I look at this equation, I say, oh, they start in the whole $7 and add $5 a week and add $2 a week. Well, let's make this more simplified. If they add $5 a week and $2 a week, how much are they really adding per week? I combine like terms. These both have x's. 5 plus 2 is 7x. And I copy down. That means this person starts in the whole 7 and adds $7 per week. This person starts in the whole and adds $7 per week. So this one's going to have infinite solutions if they start the same amount and add the same amount. How could I do this with algebra? I'm going to switch things up. Let's say this is my variable side and this is my number side. Okay, get rid of the variable. -7 equals -7. Hey, they are the same number on both sides. I don't even need to get it to 0 equals 0. Infinite solutions. Let's try one more. Let's draw our line. I don't know what's going on, so I'm going to distribute. I have 2x minus 6 equals 6 minus 2x. Now, be careful. These look very similar. They both have 6 and they both have an 2x. But notice this is -6 and this is +6. So this person starts in the whole $6 and this person starts at $6. 2x is positive, so this person's adding $2. This is a -2x. So this person's taking away. So the same situation is not occurring. They don't have the same starting point, so I actually have to solve this with algebra. I think there's going to be one solution, but let's check. Draw my line of balance. Positive 2x is bigger. So this is my variable side. That's my number side. Add 6. I'm left with 2x is equal to, notice this does not zero out. This is 12 minus 2x. I bring that down. If this is my number side, get rid of the variable, plus 2x. Notice this, plus 2x. Notice this does not cancel out. 2 plus 2 is positive 4. And I can solve. Divided by 4, x is equal to 3. If you have any questions, please reach out to your teacher. Good luck on your assignment, and have a good day.